Last question in paper 1 of the 2013 Higher Maths. 3 points in 3 dimensions, show that these points are collinear, and the usual second part to find the ratio in which t divides a and b. Well, so we drawing here. There's a, presumably t's there because you have to show they're collinear, and there's b. The way they show they're collinear is get the vectors. You could use the vector at, or displacement at, and AB or TB would be better if I want the 2 parts for the ratio. So AT, that would be T minus A. So that's 3, 2, 5, take away -7, -8, 1. 3 take away -7 is 3 plus 7 is 10. Take away -8 is plus 8 is again 10. 5 take away 1 is 4. So 8 going from A to T is 10 along, 10 back, and 4 up into the air. Similarly, what is it from T to B? Well, that'll be B minus T. B is 18, 17, 11, and T is 3, 2, 5. So that would be 18 take away 3 is 15, 17 take away 2 is also 15, 11 take away 5, that's 6. So when it comes to the ratio part, you can see that this step is smaller than that step. Now, for them to be in the same ratio, all the corresponding components must be in the same ratio. I think I'll do it in the order of, well, I'll do the smallest first in this case. 10 over 15 has to be the same as 10 over 15. It must be the same as 4 over 6, and they all cancel down to 2 upon 3. So I can say that AT is 2 upon 3 times TB. Then I just have to go through all that business. If one vector is a multiple of another vector, that means that they're parallel. That means that AT is parallel, you can write that in words if you like, to TB. That's not enough to prove they're collinear. Vectors can be parallel without actually joining. So the next part would be you'd have to make a statement, since they're joined at T, since T is a common point. That means now that A, T and B are collinear. And the ratio just comes from this expression here. I've got AT equals 2/3 of TB. Writing it as a fraction, because that's what a ratio is, it's a fraction. I've got the fraction that AT is of TB is 2 over 3. So that must be 2 and that must be 3. So when it says, what ratio does T cut AB? I've not left myself a lot of room. T cuts AB in the ratio 2 to 3. Then part B. C lies on the x-axis and TB, which I preserved here, is perpendicular to TC. Well, if C lies on the x-axis, that'd be X, Y and Z. If you're on the x-axis, you've got an x coordinate, so I'll just call that X, but it's 0 for the Y and it's 0 for the Z. Which means if you want TC, which will be C minus T, you will have C is x 0, 0 minus T is 3, 2, 5. So that would be x minus 3, -2, -5. And if TB is perpendicular to TC, that means that TB dot TC must equal 0. The scalar product must be 0 if they're perpendicular. So I'll just work that through. X minus 3, -2, -5, dot 15, 15, 6 must equal 0. Not let myself a lot of room. So I've got 15 times x minus 3 plus 15 times -2 plus 6 times -5 should come to 0. So what's that? 15x minus 45 minus 30 minus 30 should equal 0. So 15x, they're all negative, that's 105 negative, bring it over as 105. 15 into 105 goes 7, x should be 7. Which means that C is the point 7, 0, 0.